A very good morning to all of you and a warm welcome. On behalf of SB Patil College of Architecture and Design, I, Architect Harshada Vazalkar, take this opportunity to welcome our Honorable Chief Guest Speaker, Architect Vivek Bhole sir. I am really thankful to our Honorable guest for taking the time out of his busy schedule for this webinar. I find immense pleasure in introducing our honorable guest speaker, Architect Vivek Bhole. Architect Vivek Bhole, principal of Neo-Modern Architect, established his practice in 1996. Since then, he has received more than 16 national and international awards. His work is published in many prestigious magazines and newspapers. Many magazines and newspapers, including a 4-page coverage by Times of India in 2013, along with a felicitation in Grand Prelude function organized by TOI. He has won many prestigious architectural competitions like redevelopment of BDD Chawl by State Government of Maharashtra, the biggest redevelopment project in the country, and won Avigna Park, the tallest occupied residential building in the country. So I am over to our honorable guest, Architect Vivek Bhole sir. So we can start our presentation. Okay. Yes, you can unmute, sir.
Yep. Thank you and good morning. So the topic is very close to my heart. My firm is already doing more than 80 high-rise towers, that is 50 plus stories in Mumbai alone. And then today I'm not focusing on to residential high-rise building. It's a topic by itself. So we'll be focusing mostly on to commercial high-rise buildings. So we have seen in past many years across the world, the skyline is changing. You can see skyline in Hong Kong, London, Chicago, Dubai. Chicago is the birthplace of high-rise buildings, where actually the definition of high-rise changed. And then we saw a huge development coming up in China, particularly somewhere near Hong Kong. Then the Twin City started popping up called Guangzhou. And then I have seen in my lifespan of this 35 years of my practice, there are 2 new cities coming in between Hong Kong and Guangzhou, and equally big high-rise cities. Then Dubai, we all know in last 25 years, Dubai has gone from where to where. I have seen these new places like Marina coming up. And then London was very, you can say, a low-rise city for centuries, suddenly got those high-rise buildings in its skyline. Not only these few cities, there are many more, like Sydney, and now even in Mumbai, you will see a lot of high-rises coming up. Now, this is inevitable because of the urbanization and then the maximum utilization of resources. The high-rises are must. So we'll be studying these topics today. We'll be talking about forms. Then more important than that, the type of structures, method of construction of these structures, particularly the concrete structures. Then I'm taking this one small turn here, tropical high-rises, just to understand, maybe explain you what is good and what is not. And then few of the case studies of my own projects. So we all know, we all are mesmerized by all these forms, particularly when it comes to high-rise, the volume, the scale, that attracts the architects and also the real estate developers, and that creates the character of the city. So you will see in many countries like Kuala Lumpur, when they had those twin towers, suddenly the real estate prices started going up and the city came onto the world map. So these are these pyramidical forms, Hancock Center in Chicago, and then this pyramidal building in San Francisco, Riyadh, and the very famous the Shard in London. Then there are a few leaning forms, like these are very fluid and parametric forms. The Capital Gate at Abu Dhabi, then we have got this Al Bida Tower in Doha, the twisting tower. There are many twisting towers across the world. Then more bolder experiments, the CCTV tower at Beijing by Eren Kulas, and then signature towers in Dubai that is being designed by Zahadi, then Apparon building in Dubai. All these forms are so mesmerizing, and we are in fact inspired by them, and most of the time when we start designing the building, we start with these forms. More understanding is required towards our architecture, our regional architecture and the regional needs, and that is what we are going to talk about. Then these aerodynamic forms, the London, the tower designed by Norman Foster, Shanghai World Financial Center next to the Jinmao Tower, then Pearl River Tower at Guangzhou. Now, these are few examples of those high-tech modern buildings. Then this is something very futuristic, the dynamic tower. This is in Dubai, and the architect is planning to do something similar in many places in the world. So all these towers are in one place. How we achieve them? Unless we know the methodology to construct design, it is not possible. And when we design a small bungalow, design or the planning aspect will preside over the structure. But then when we design a high-rise tower, that too a super high-rise tower, the structural system is the most important. We say the high-rise building will fail, the design will fail only if your structure will fail. And the second is your vertical transport, because these buildings are so massive and the number of users are more. So if your vertical transport system is not adequate enough or not managed properly or not designed properly, it will reduce the functionality of the building. In the types of structures, very basic is concrete frame tube, where the central core is going from the center of gravity of the building, and which takes care of all the lateral forces. In high-rise building, more than gravitational force, the horizontal forces by wind pressure and the seismic forces, they are more stringent. And when you go much more taller, then the wind pressure will govern the entire design of the building. So how to take care of the horizontal forces? The better idea is not to increase the size of the peripheral columns, but just take the horizontal lateral load onto the central core, and the peripheral column, the skin of the building, will pass on that load through either the structural system, structural slabs or beams, or various other means. We are going to discuss them to the central core, and you get maximum utilization of the space around it. So the first is concrete frame tube. Now this building type is up to 60 floors. The time you go little above than that, then you need a steel structure. So because you want to restrict the sizes of the peripheral column, you either go for steel components or you go for composite steel component. Now when I say composite steel component, that means the steel tubes and the concrete poured into it. So generally fire safety is very important when we use steel, and we have to either cover the entire structural members of the towers with concrete. We have to encase them, but instead of that, if you pour concrete inside the hollow tubes, you get much more strength, but then for fire safety, you will have to go for different alternative means like vermiculite plaster also. Then the third type is tube in tube. There are very few buildings of this type, but then I certainly will not suggest somebody to do tube in tube, but in India, the codal requirement restrict you to a slenderness ratio of 12. That means the building height will not be more than 12 times the width of the building. But there are few buildings across the world where the slenderness ratio is more than 12. It is 15, 16. So in those types, if at all they decide to do it in concrete, therefore they go for tube in tube kind of thing. Then there are concrete brace tubes where the concrete will be used in a diagonal fashion in the peripheral tube. The central core again remains same. The fifth type is steel brace tube. We'll see how these kind of structures look like and how you utilize them. The most famous or the most preferred one in current scenario in latest few buildings, what we are seeing across the world is steel diagrid. The reason why we use steel diagrid is because of its economical factor, flexibility, and more than that, the flexibility of the form. The shapes what we just saw in our previous slides. To achieve them, you need to have those kind of structure. So the steel diagrid where the central core is still there, but the outer skin is of a diagrid structure, and you can achieve almost any shape or any form out of it. Then a very well-known, again, this is a little bit evolution of steel diagrid, which is exoskeleton. Now they are very near to each other. Exoskeleton again is something similar where the external skin becomes the structural element, and you can have actually the facade element and the structural element one and same. So your central core is still the same. Now, if you go for steel bundle tubes or concrete bundle tubes, there the central core is missing because the individual squares what you see in the plan below, they are actually core by itself, and they form a sturdy core, and the combination of these bundled concrete tubes, they make the structure. And then the steel based tubes or without interior columns, this is something very interesting, something similar to steel based tube, but that is still having the central core inside. Here the central core is eliminated. When that is possible, now these type of buildings can go up to 150 odd floors. If you want furthermore, then there are space truss. So we'll see few examples of space truss again, and then something called super frames. Now the space truss and super frames, and even in many other types, you can have the combination and the very well-known concept that is a super column. So instead of having all those small columns, we have few super columns in the outer peripheral scheme, which takes care of maximum gravitational forces, and with connections in between the few floors that passes on the horizontal forces to the central core, or they work in tandem with each other and they take care of the horizontal forces. So these are the few types of structural system. If you want to go into detail, like concrete frame tube, as I said, the central core, you will see the central core here. Yeah, so the central core here, and then the peripheral columns all across, and in between there are these outriggers. These outriggers actually connect the skin with the central core, and not on every floor, at few floors depending upon the structural design, but then they take care of the transfer of the horizontal forces to the central core, and they reduce the deflection as well. So you will find all across the world these kind of building where the central core is accommodating number of elevators. Like few of the towers in Hong Kong, like Chung Kong Tower, they have got more than 50, 60 elevators, and then staircase, toilets, and then the peripheral columns create the skin. So this is called a frame tube, because these peripheral columns, they form a frame. You know what is frame structure? Frame structure is where you have got columns connected with the beams. So that is what is forming at the periphery. That is why this is called frame tube concrete structure. And the typical building units are like this, where you have got at lower level a bigger core, the core gets reduced and then further reduces, and then you get a very interesting form out of it. So you'll find number of these kind of buildings across the world, like Trump Tower, etc. Then concrete tube in tube. This is 432 Park Avenue in New York. So when we saw this building for the first time, it has got good visibility from the garden, the main central garden of New York. And the slenderness ratio amazes you, because the slenderness ratio is 15, which is very high. And when you achieve that slenderness ratio of 15, see the way they have done it, the open drums are actually the places where they have placed the outriggers. The central core is still there, and the outer peripherals are not exactly the columns and the beams, but it's a core again with punctures. So even in the central core, you will find the punctures to access various spaces. Something similar is happening on the outer side. The whole outer skin will be considered as a concrete tube with punctures. And this is how you can treat this, you can handle the slenderness ratio. And then there are these TMD dampers to take care of the sway. So in super high-rise structures, the sway is there, and you must have heard about this. There is a mass which is placed on the upper floor. When the building sways on one side, the mass goes on the other side, and it counterbalances the deflection. And that is how we control the deflection. Now, how much deflection one building can have? So, like I have visited many high-rise buildings across the world. So one of the buildings, they said that deflection is happening around 2 feet. So 2 feet of sway will make the building very uncomfortable. But it is so slow that you don't actually understand that there is a sway. And that happens only in those extreme severe situations where the hurricane is there. So in those towers, to counteract the sway, these different types of these dampers are used. Then these are steel brace tube. Now there are different ways you can actually brace the vertical columns. So X bracing, 2-tier X bracing, or we have got V bracing. And then number of these different bracings, they actually control the deflection, and they actually make a frame out of those vertical elements. So you can see the John Hancock Tower in Chicago. It's almost like 60 years old building, and designed by SOM, and one of the very few first buildings in Chicago. So they use this system. There are a few more, like 33 Canada Square in London, then Aloka San Francisco. They are onto the same concept. This is very favorite building of mine. I have seen one presentation done by the firm. Zahadid designed this, and I witnessed the presentation in one of the CTBH conference. And the conference was in Shenzhen. Immediately after the conference, we went to see this building. The entire structural system, the steel die grid. This is a steel die grid which is also exoskeleton, which is outside the glass facade. And all these steel members are cladded with solid core aluminum. Now you can see different ways of designing exoskeleton or die grid structures. So you can have those outer die grid members inclined, or you can have very fancy shape. You will find number of these variants across the world now, and many high-rise buildings are coming up in this way. This is a proper exact example of exoskeleton, not exactly the high-rise one, but because I wanted you to understand what is exoskeleton. The structural system is part of the facade itself, and it doesn't really require any additional structural member. So this is not a dummy one. So many of these kind of structures which we saw in India in last decade, they are dummy. So we see that die grid, which is actually a facade element, but the structural elements are inside and they are different, they are away from the facade. So they are not exactly the exoskeleton buildings. This is one very popular example of bundle tubes. Again, one kind of pioneer in towers. This was one of the time the tallest residential and commercial tower in Chicago. Sears Tower, now it is called Willis Tower. It has got the concept of those bundle tubes. So each and every that cuboid member is a core by itself. So it doesn't have a separate core to take care of horizontal forces. All the members are acting as a core. Space structure, we know these two popular buildings, the Bank of China in Hong Kong by IMP, a very famous building for particularly this concept, a space truss structure. So if you see in the diagram, you will understand that this structural system, the external structural system, which is going to take the gravitational forces of all the floors, is actually designed in such a way that almost like 12 to 15 floors are being taken care by that one cross bracing. So this takes care of both the lateral as well as vertical load. This is the specialty of. So there is no need of, in fact, the central core in this. If you have got a central core, it's an added stiffening of that tower. And then, as I said, very interesting concept of super columns. Many high-rise buildings which are coming up recently to achieve those different forms are with these super columns, where the central core is still there. But then, like if you see, the super column can be of any shape, and they act as a structural system for the entire building. So you just imagine a tubular structure, just scaled it up to the height of the building, and then you achieve a different form altogether. So this is 1,000 museums at Miami by, again, Zaha. Then this Jinmao Tower at Beijing, I stayed in this hotel on 67th floor, and I had a nightmare because the building had a sway. And because the building has got little older, the facade that time, because this is the, I think building has got almost like 20 years ago, this building was constructed. So because of the sway, the whole facade system was making a sound. It's a high tower, it's a grand high tower, and then in the night you cannot sleep because there is this cracking sound of the facade is there. But then a very interesting concept, this was one of its kind. Like these are those super columns on all four sides in the corner. They take care of the maximum lateral forces. The core is actually missing. If you see, the central atrium is there and there is no core as such. So the super column are forming the structural system for the lateral pressure. So these are few types of these high-rise buildings, and we'll be studying few which are designed by our firm in different types. Before that, we'll see few construction methods and techniques. When it comes to concrete, most of you must be knowing aluform. Aluform is something similar to what we generally do, except that the shuttering is aluminum, and every part of the building takes part in the structural system. So if you have heard about a My1 shuttering, because it's like a brand name. My1 is a manufacturer's name, but people call all aluminum shuttering as My1. So aluform is something similar to this, where you don't just cast one column, then the beams and the slabs and staircase separately. It's like the whole floor will be casted in one go, and the shuttering is then taken ahead on the next floor. So it's like you make a mold out of this aluminum panels, and you pour inside the concrete in one go. So if you see the staircase, the beams, the columns, the walls, everything will be casted in one go. So the construction is monolithic, the speed is faster, and the efficiency of the concrete is there. So you get additional carpet area out of it. So there are many benefits of it. And particularly in India, because of the restriction on the sand, which we use in the concrete and the plaster, we cannot actually get good quality of sand in many parts of India. There is a lot of silt and salt content. So in such cases, the crushed stone can be used in the concrete, and the plaster, the sand plaster, mortar plaster is totally eliminated in this entire construction methodology. In fact, in all the structural systems, in all my buildings, we are avoiding plaster completely. So external fascia is either concrete directly. If there is a cladding, then it will be cladded. From inside, there is no plaster. We'll just put some gypsum plaster or something like plastic putty kind of thing. So now plaster being the weakest part need to be avoided. This is the concept of aluform. Then a slip form shuttering, slip form where particularly, if you must have noticed, the concreting of the road happens where the concreting is happening and the machine is moving ahead. It's a horizontal slip form. Now just imagine using the same methodology for vertical erection of the building. So the central core, most of the time, people prefer to use slip form where the concreting is happening. You can see in the diagram, there is a concrete, this supply is from the top with the help of the crane, the hopper, and then the entire the formwork and the scaffolding takes care of everything, including the safety. And then the shuttering and this whole system keeps on going up with the hydraulic jacks. Now, jump form is something similar to this, but this is not exactly sliding, but it is going above one floor. It goes just, it jumps for one entire floor. So you can see in the diagram here, they pour the concrete inside the members, and they then take the entire shuttering on one floor above. So this is a very popular system for doing high-rise buildings. We are using it in many of our high-rise projects. So a combination of jump form and aluform, that is what is most preferred nowadays. This is one more system where this table forms or flying forms. The tables are lifted by the crane and placed, and then this gutter kind of formwork, the ready-made shuttering is there for the beams, and then the entire slab can be constructed. Again, these tables can be taken from below and lifted and kept on the top. So it is called flying form shuttering. This is one more popular way of doing concreting where the speed of the construction is very fast. In fact, many of the Turkish companies, they claim that almost in 36 hours you can cast a floor. So the initial concrete strength can be achieved, and then with some minimal supports kept in intact, the tunnel shuttering can go above and cast within the next 36 hours. So the speed is very good. In all other shuttering system, what we saw, construction methods we saw, the cycle is from 5 days to 10 days. Now to achieve this 5-day cycle, because the concrete maximum strength is achieved in let's say 28 days or 21 days, depending upon the concrete, how you achieve the removal of the shuttering and the supporting system within 5 days is by adding, keeping the additional supporting system, the acrospan, acropops, which are required for the structural members, and then you achieve that cycle. Here also in tunnel form, these tunnel form units are inserted from the side of the building. So every building has got fenestration. So the opening for windows, from there the tunnel form unit goes inside. The side, the end unit is sliding form unit, and this is how the construction happens. But then it gives a lot of restrictions on the design of your building. So you cannot have those column-free high-rise buildings, particularly the commercial high-rise building in tunnel form, because of the limitations of the form itself. So this is all about those modern buildings we talked about. Now, what is needed, that is need to be discussed here. We being a tropical country, if you see the red zone, we are into 60% of our India is into tropical zone, and then a remaining 30 out of 40%, 30% is into subtropical zone. So we need to understand what are tropical high rises. So I'm just giving you a few sample cases, and then we'll move ahead to the case studies. So this is one building I visited in Sydney. So it has got a mall, it has got residential towers, commercial development. It's a mixed-use development basically, and you'll see a lot of that greenery happening onto the facade of the building, because most of these urban development, there is hardly anything to offer in terms of greenery in the surrounding, although they have got some good lawn, but then many of these buildings, they don't have anything else, so they try to do it on the facade. The element, what you see, the cantilever element, they are the reflectors. They reflect the sunlight onto the atrium of the mall, which is below. So there is a mall, which is underground mall here, and the atrium is lighted by the reflector above. It's a, I don't really approve this as a platinum rated green building. I will not approve this as a really genuine effort. It's more of a stunt. Cantilevering that entire huge 20 meter of element out of the building itself is a task. So you see the atrium below and the mall underground. So all the lawn, what you saw, there is a mall below, and this is the skylight, and the light comes inside the mall. So it's a naturally lit mall. And then because this development was part of some old factory, there was a lot of restriction in terms of heritage. So they had something to preserve. So there are a lot of interesting efforts they have done into this. And from the side, you can see how the greenery is maintained. Because this is a residential building, even in a commercial building, if you can give a peripheral flower beds and accessible flower bed, you can maintain a greenery, and that can give a very good, a livable environment for the insider as well as the outsider. This is one more project. This is at Singapore. Now, Singapore is a place where you will see all the good tropical buildings. Oh, this is not a high-rise building, I know, but then it's a commercial building, and then you can see the amount of greenery they could maintain on this. And because this is a hotel and commercial building, of course, a mall below, you can see the way they have actually done the landscaping on it. So at the bottom level, it's a retail space, and you can see that triple height of arrival and that public realm they have created below the canopy and those triple height spaces. This is the entrance lobby of the hotel, and you can see the section now. Very interestingly, they have created this porous environment within the building. So making a massive building without greenery is what is being forced on us with additional FSI they are giving in most of the cities, but then Singapore has got a huge FSI, but still they could manage it with those porous forms. Again, something similar. This is OSI hotel at Singapore. Again, I have stayed in this hotel, and very interesting. Whatever form you see, there is a lot of porosity inside it. The outer skin in aluminum with a lot of greenery, and then those inner pockets, they have got this natural landscape happening. So if you see the plan here, the building footprint at the hotel level is something which is like in L shape, and you'll see this lot of hollow which is happening here, and then in some places here. So the outer skin is giving that entire form to this haphazard structure, but it doesn't look like haphazard. It looks very interesting because it creates those semi-covered spaces which are within the building. Now, with the bylaws we are facing in Mumbai and most of the part of India, we may not be able to execute this kind of project, but someday we'll get this freedom and we'll be doing this, something similar to this. Then look at those sky lobbies and there's a restaurant there, and from the top, the crown part. Now this crown is like 10 floors high crown. It's a hollow space, and hardly 2 or 3 floors you require for your outdoor units, AC outdoor units. The remaining is to just create the character of it. They could have actually gone for some photovoltaic elements there to generate alternate source of energy, but then I think the designers, they tried to achieve the form and that greenery, the overall concept through that outer skin. Moving to the case studies. This is the first project. We are doing this for a group called Prestige from Bangalore, but the project is in Mulund in Mumbai. Now, this is very scenic site. I got a hill on the rear side, and in the rainy season, you actually see the clouds coming down. And then this is properly a residential area. Then why I'm making a commercial building there? This is a question. So this is a very huge development, more than 1.5 crore square feet of it. And we already started 6 towers, 55 story plus. And this is like, when we have got so much of residential, when you make a mixed use development, you give people choice for not to travel and go directly to their workplaces. And that is what is going to be the ideal scenario in coming days. So this is the entire layout. So we have got these 2 sectors right now under construction. They are 55 story twin towers. These are again 55 story 6 towers. We have got 60 storied 4 towers, but these are like very premium, super premium kind of thing. 4-bedroom and 3-bedroom high-end apartments with terraces, decks, etc. And this is where this commercial building is coming up. There are different obligations on the project, so the commercial building was a mandatory kind of thing. But then we thought of making it a part of this mixed-use development to give them that workplace comfort. When it comes to a commercial building, very important factor is the column grid, the structural grid. So, as I said, any commercial development, because the load is almost twice of the residential building, live load, even the dead load is more, and you require column tree spaces. And as I told you, for designing a high-rise tower, you require a structural system. So here the structural system is central core with peripheral frame tubes. So the grid is like 7.5 meter by 12.5 meters, particularly designed for the parking and the column-free office spaces. Then we wanted like free movement of cars, because this building is like 8.5 lakh square feet of carpet area. Considering the basic minimum requirement of 75 square feet per person, you'll have more than 11,000 people working there. But if we really say in Mumbai, there are many office spaces where the density is more than 35, less than 35 square feet per person. In that scenario, the user load will be tremendous. Now, you require a good movement space there, particularly the separation of pedestrian as well as vehicle movement. Luckily, I have got a scenario where my surrounding road, there are 2 roads, it's a corner side. So the 2 roads has got a level difference of 6 meters. So at this junction where I have got 0 level, I come above up to 3 meters and then I reach to 6 meters. So we thought of using all these different levels to take care of different entries and exits. Then the requirement was so peculiar that we had parking in the basement. Then we wanted to have a complete lobby on the ground floor and part of it on the first floor, and then the podium on top, and then the office floors above. Now, this makes it really very tricky, because you enter at some level without disturbing your lobby, the entrance lobby. Because see, as I told you, more than 11,000 people are going to come there. And in commercial building, the most tricky is the vertical transport, as told you already, because the peak hour is very less. In residential building, we consider the peak hour of 6 hours. But in commercial building, the peak hour is hardly 1.5 hours. So in the morning, 9:30 to 11 o'clock, that is the maximum user load you have to take care. And the same thing is going to happen in the reverse direction in the evening. So your vertical transport has to take care of that. And to take care of that kind of user load, you need to have a good waiting space. So lobby is very important. Now, I didn't really want to disconnect the lobby because of the parking in the basement and above the lobby. So I kept a Caesar ramp. Now, this is a very interesting concept. This is a Caesar ramp which is inside. So Caesar ramp is a concept where a ramp is always helical. When you go for multi-storied, multi-level parking, it's a helical ramp. But just imagine two ramps parallel to each other going up. So one can be used for going up, the other can be used for coming down. So they are interlinked two ramps. So what happens? One loop of this ramp actually climbs 2 floors. And this acts as a bridge in between. So that these two ramps are connected by that bridge. So every ramp is accessible to every level. And you have got separate 1 6-meter ramp for going up, separate ramp to come down. We have executed something similar in one building which is just in the front of in this layout. Very difficult to understand unless, but you can do little R&D on this, and there is something called a Caesar staircase as well. So you can actually have 2 staircases of 2-meter width in actually a space which is only 50% more than a normal staircase. And believe me, they are like watertight staircases. From one staircase, you cannot enter into the other one. So there are actually 2 separate staircases interlinked in each other. You can Google on this. So we had very efficient driveway and doubly loaded parking on both the sides. And this series of elevators, but these elevators are not accessible for the parking levels. The parking levels, the accessibility is only given to the side elevators, which takes them into the lobby. This is from the roadside. Now, these are those podiums, the green podiums, and then the tower above. So on the ground floor, as I told you, there is a lot of movement is going to happen. So this place is where this vehicular movement is going to happen. And people, once they enter, this is a triple height entrance lobby here. And then you go across here, there are those flap barriers which will control the access. And then you can go to the control zone. So this is a control zone. Not everybody can enter into this without a proper authority. And then you can take the lifts particular to your wing. Now, what we have done here, if you see the entry at this lower level is at 0 level, this entry is at 4.5 meter level, and this entry is going, it's climbing up, and from here at 1.5 meter level, I'm actually entering into the basement. So if you, that level is not there, but then, so I'm entering my basement here, and then I'm entering into my another basement here. I've got one more entry here as well to the basement. So that basement plan is some, I think it's missing or it's there in the next slide. But then upper level is for the vehicular traffic. So on the rear side, I have got these waiting lounges, I have got cafeteria, I have got a small coffee shop kind of thing here. In the lower ground, yeah, I was talking about these entrances here. So if you see, this is the lower ground. So one level below this entrance level. So when I enter at 00, I entered into the basement here, or I enter into the service lobby here, or this is the exit. So I can take an exit, I go out from here. So now this Caesar ramp will lead me to one ramp will go up, one ramp will go down. If I come here, again, I got one ramp going up, one ramp coming down, because these are actually two helical ramps, as I said. And then I've got a huge food court with stalls on one side, and then a food court with a service lobby and service storages here. This is one level below the food court. So I've got a full basement there. My services are there, and efficient parking. You can see all the driveways are doubly loaded. So to achieve good parking, you need to have two things. One, good column grid, so that you don't waste your space, and efficient driveways. Preferably, one should not have dead ends into the driveways, but then sometimes it is inevitable, but I prefer not to have dead ends. This is a basement too. You will always find a loop happening all across, so that the car movement is smooth, and preferably one-way movement. So again, my services there. And this is a typical podium. So from first floor to fifth floor, I've got the ramp which are going up in the middle here. And then the driveway in the periphery. This is going to be the bridge. This is just a first cut view of the podium. And then the amenity floor plan. With such a big offices, you require a lot of amenities like multi-purpose hall. You require creation, daycare center, library, meeting rooms, conferences, banquets, gaming zone, fitness centers. And there is one big 13,700 square feet of a plaza in the middle, which is a atrium which is covered at the top of the tower. So you'll see all my amenities which are arranged in the periphery. Now, person without proper authority will not be able to access these amenities. So you will see a lot of those flap barriers at the entry levels controlling those entries into the amenity area. So just a close up of that. We have got all these amenities. Nowadays, this is important. More than that, now the amendment is going to be there. One whole floor they are going to keep for a WeWork kind of thing, a co-working space at the lower level. And then the typical floor plan. Now, as I explained you, the column grids, like these are the columns in the periphery, not going to take care of any lateral force. All the lateral forces are going to be taken care of by the central core. There's a huge concrete mass which is going to take care of that. If you divide this building into 4 corners, so you consider this as one wing. So when we see those number of elevators, in fact, when I started presentation to my client, if you have heard about Prestige, they have executed more than 2 crore square feet of commercial spaces in Bangalore alone. They were not really convinced with the idea of having those many elevators in the center, but because the requirement was such, and when we showed them this, I told them this is going to be one wing. And just because all the wings are interconnected, you are seeing that series. So there are only 7 elevators. And those service elevators are common for all the 4 wings. So when you've got only 7 or 8 elevators per wing for such a huge user load, then it is sufficient. He was a little skeptical. So we had to do the entire analysis, the lift analysis. And then they accepted this. So this is 7th and 14th floor refuge area. So all my corners convert into refuge areas accessible from the common corridor. And 21st floor, I have got this terrace in the corner. 25th and 26th floor plan, you can see I have removed those corner offices just to get that character of pinnacle, the form which is reducing on the top. And then the skylight, which is covering the atrium and the plaza below. And then the terrace floor plan. This is a schematic plan where we have got those basements below, the ground level, as I explained you, then the parking which is there on top of the entrance. Now, if I could explain you properly, the Caesar ramps are actually acting in this central zone here. They are connected. So when I enter in the basement, I can actually go inside at the ground level. I can go inside the basement, and the same ramp I take to go up for the upper levels without disturbing my lobby at the ground level. And this is the view. These are the basic parameters. It's 8,34,000 square foot of FSI. So almost similar carpet is there. Total built-up area is around 18,74,000 because of the services, parking. The total height of the building is restricted to 120 meters. So 26 habitable floors, plus podium, plus amenities, etc. And then a 2-level basement, 5-level parking. The FSI versus carpet efficiency. This is very important because what you construct, if you cannot sell, is not going to be useful. So that is 95%. This is a kind of lobby which we want, a triple height lobby. And then in the particularly this project, as I said, it was very important to convince my client for those number of elevators. And I had to literally tell them that although you have constructed 2 crore square feet, but you have never constructed a high-rise tower in a high-rise commercial tower, where the peak load is only 1.5 hours, and you'll have to take care of that much of user load, and you require those many number of elevators. So I had to do this analysis. So we sat with different consultants. So I worked with Lodge Bates, Tak Matthews, and then many other consultants, along with this lift companies for various of my projects. So I took consultants' help to generate this, where I wanted the maximum traveling time, not more than 1 minute, maximum waiting time, not more than 1 minute. And to achieve this, we studied different variations, and then we tried to change those parameters and did the iterations to achieve maximum efficiency in terms of the traveling time and the user load, and on one side the cost. So if you see here, we tried to change the number of elevators. If the number of elevators are 6, what will happen? If number of elevators are 8, how much handling capacity it can take care? Then if I change the speed of the elevator, because changing the speed changes the, it is very important factor for cost implications. Just for the sake of example, at 2.5 meter speed of elevator, let's say if it is costing 30 lakh rupees, if I go for 6 meter speed, it will cost me 2 crore rupees. And if I go for 9, it will cost furthermore. So here the maximum speed what we tried was only 3 meters per second, because the building is not super tall building. My next case studies are super tall. So we'll see even up to 9 meters of per second speed. Then here we tried to play with the size of the elevator, like 19 passenger, 21 passenger, 23 passenger, what will happen? And then the group population. So we tried all these iterations and we came up with the solution. So this was the first project. Now, why particularly I showed this project? Because it's a voluminous high-rise commercial building. We don't have many tall commercial buildings in this part of Mumbai, although there are many in the city side. This is a different structural system, my case study number 2. This we designed in Bangalore, a twin tower at Bangalore. And so I'll not take your time on to what Bangalore is. We all know Bangalore has got some heritage. Bangalore is a cosmopolitan city, and it's a capital. So my project brief was like, I had to design basement for parking. All the basement was into the parking. Twin tower, I had to design. The minimum floors were 50 floors. And then I used the technology which is steel and concrete composite. Then the total emphasis was onto the reduction of the time. So that is why the technology was very important. And then, of course, various planning aspects were there. So this was the scope of my work. So we wanted to create a building which is like a livable building, a building with a lot of greenery into it, technology into it. All these high-rise buildings, they're masterpieces of technology. And if you use technology in a wrong way, you end up into a goof. So whether it is a structural system, vertical transport system, facade system, automation, everywhere the technology is very important. And then the first is cost-effective site utilization and the livability of the site. So these are few factors we considered, we thought of them, and we incorporated them into the greenery and the spaces we designed. You'll see them in the presentation, the architectural part of it. I'll just skip with these few slides. There are many of them. Okay, so here we are. This is the entire layout. I have got two side roads. The entry was to be taken from these two sides, here and here. And this road was almost like 20 feet below this road. So this site is not accessible from Dhanvantari Road. This is the existing office building, and this is the existing temple. Both these structures were to be retained, and they had a few requirements like this. Just a minute. So if you note this two bridges, these are the skywalks. One is connecting to the Vidhan Sabha and the other is connecting to the bus terminal. And then we have got these different levels. So all different colors, what you are seeing in the layout are at different levels. So as I explained, you see 907 is the level here, 908 is the level here, so 907. So this whole zone is in 1 meter of level difference here. But suddenly the top of 20 meters is there. This is at 897, not 20 meters, 20 feet. Yep. So this is at 897, 898 kind of level here at the lower level. And then these are the views. Like on one side, I am seeing this race course. On one side, I'm seeing this golf course, the Mantri Square, Bengaluru railway station on this side, and this majestic bus stand. This is what we wanted to connect with the building with the skywalk. And then the Freedom Park and Cuban Park. These are the two parks which are visible on this direction. So how you achieve the economy by reducing the footprint of the building, because anyway we had to go for 50 stories, and with the structural system we selected in such a way that it will give me maximum economy. So we'll see that in the next few slides. The economy comes with the structural system. The core is very important. So I had a very sturdy and stiff core here. All my elevators inside and the peripheral column system. So all these black dots are my columns there. And then a facade, which is a precast facade in the periphery. So core area is only 23% of the total building footprint. And the vertical transport, I have achieved that 1 meter waiting time and 1 minute waiting time, 1 minute travel time by having few express elevators. So again, they are in next few slides. So I explained you the site orientation, not waste time on this. Yeah, this is what is there on the site today. So the entrance, existing structures, and then the road, which is the corner, the junction of that plot is here. And this is how the building is oriented, particularly because we wanted to retain both the structures, and the red line indicates the level difference between the site. The level is suddenly dropping down behind that red line. This is where the maximum good view is there, and from this is where the building will have good view. So people will note the building from these angles, which are marked in yellow arrows. So we oriented the building in such a way that the heat gain is minimum and approximately like 30 to 40 degrees north. So all my glass elements, they're getting the vertical sun shading devices shadowing onto them. This is the massing. So starting from this, there is this porch below, and this is actually skywalk written wrongly. Amenity block here. Then these are co-working blocks. So both these are co-working blocks. Then I have got a wellness center block, which is in the middle of these two wings. Then I have got this central, the main towers here. These are the refuge areas. Then there are these two sky bridges which are connecting these two towers at two strategic locations. And then this is a viewing gallery on top, and we have got VIP offices, and then spire on the top. So we did a shadow analysis just to check what is the orientation was not defined by the shadow analysis, but at least we could check that they're working properly. So if you see the shadows are falling in such a way, here in most of the time you'll see shadows are in a diagonal way. So that is actually supporting your vertical fins to give minimum heat transmission onto your glass elements. So these two red lines are actually the skywalks which are connecting Vidhan Sudha and the bus Majestic bus terminal. For internal, these are the vehicular movements. The green is entry to the existing building, which they wanted away from this proposed building. These are the entry and exit points. Pedestrian movement. I wanted totally segregated pedestrian movement away from the vehicular movement. So we created those colonnades also to regulate those movement. We'll show in the next few slides. And then this is the a grand porch and then a grand lobby which is leading to both the wings. So these are those double height lobbies. You enter into those double height lobbies through the main lobby, and from there you take those express elevators for the upper levels. Landscape is a very integral part of architecture design. Particularly for this project, we were very careful about it. We divided this whole into different zones, and then, like we said, life, space, and buildings. And we created that different hierarchy into that, and we segregated different zones. So public zones are there because there are few people who we will not allow them on the upper levels. This is an office building, security is important, but there are amenities which will be accessible for visitors. So the public zones are defined and very well defined by the landscape also. The circulation is very important. So there also we have segregated visitors and the users, and we have used a lot of landscape in the facade here. Okay, I'll not go into this in detail because there are two more projects to explain, but then we had a lot of thought process in designing those green spaces. We had a lot of interactions with the landscape architect, and then because I had those terraces, we wanted that design to be biophilic, So the interior space and the exterior space, they should be just extension of that interior space, and how efficiently we use them, because any landscape area which is not accessible or not useful functionally will not be maintained. So we wanted every part of that landscape to be useful. Then the design approach was like we had we wanted to create one good impression at the entrance, the vistas, the grandeur, the top-up experience. So we created an artificial mound. I'll show that. Then there was some area which we created a mini forest kind of thing where people can sit inside those shadowing trees. Outdoor gym was there, and then jogging track is planned on the top of the podium. So we have got podiums at different levels. So in one of the podium we give access of the jogging track through the wellness center. Then at podium levels, we created that space which is a spillover of restaurants where people can sit and have lunch. And then there is a lot of there are a lot of activities which are we say stress relieving activities, and then community activities like people meeting, having good discussion. There's amphitheater, and then finally on the rooftop we have got some very VIP offices. So we have got landscape which is connected to that as well. So this was the designing approach where we wanted to give them the work and life balance. So it's not just they are working there; it's like they are spending maximum time of their life in those spaces, because anyway they go for sleeping and eating at home, but when they are awake, they are in this space. So again, this is the approach what we had. All those porous elements what we created and those taped elements we created, we had uniformly distributed. You will see that into our design, how we actually created that interaction of spaces with the interior spaces, the green spaces, open to sky spaces with the covered spaces. So this is at podium level 1, and here you will see everything very orderly, because this is where it's a restricted area. This is the area where not everybody can visit and go and see unless they are the user of the building. So this you'll see everything is linear, and this is the place where there will be collaboration meetings and all those kind of cabanas that is placed. At podium level 2, we have got this is like relaxing areas. Again, people sitting there, but everybody can access these areas. This is kind of again, entry is restricted, but to not that great extent. Here, people can sit and enjoy these spaces. This is the foreground space. So when you enter, this is what you are going to see. So you will see that artificial mound which we have created in front of that huge porch, and it's a sloping round so that you get that good view from the road as well. In the rear side, we have got this amphitheater. On the front side, we have got that space where people will see it and they can enjoy that expanse of the building. This is the plant palette. We wanted a really interesting, combination of plantation, right from coloring to the foliage. We had a lot of discussion on this, and this is how the top picture is. Again, the other side. So when it comes to aesthetics of the building, the element, the vertical elements, they accentuate that verticality. Your vertical building looks more vertical. If you see these examples, how those vertical elements, and they are my sun-shading devices as well. Then spires are always inspiring. So you'll see all across the world, the building, the tallest building, when they claim to be the tallest of the city or the country, they achieve one more bonus height through that spire. It is not just for the sake of aesthetics or a symbol of victory. It's functional as well. It's a lightning arrestor. Sometimes it is antenna, but lightning arrestor for sure. And that gives that the iconic element to the building. So my spire was like the tapering element, right, starting right from the building. The last floor is also usable, almost like 4,000 square feet of usable space is there. And then the spire is there. So it's a functional spire. And then this is where the maximum appreciation has to happen, because this is the most visible angle from the flyover, from the junction of the road to the building. I always believe that any building which has got a character, which you remember, you don't remember it by the detailing all the time, because if you are just a passerby, you see the glimpse of it and you remember the building by its silhouette, not by the elements, the outline of the building. So how the building outline was achieved with those punctures in between created because of those two sky bridges. There's a lobby. The lobby at the other level. And then this is just a lighting concept. So lighting will keep on adding gradually, depending upon the day, the festive season, and the time of the evening. The lighting can be simulated. This is the detailing we use, pixel line detail. You have a tremendous, you get tremendous flexibility when you use these kind of fixtures. A lot of green building considerations were there, because we wanted this building to be a platinum rated green building. Small detailing, a lot of thought process was behind it. So not going into the detail, but then there are many slides on this. More than that, we wanted this building to be, not just a green building for the namesake, but actually a good livable building. So we have got this green roof, all those green, the heat island effect to be negated with those native plantation, and then we have got good rainwater harvesting, outdoor green spaces you saw, and then a very high performance building envelope. Now, building envelope is forming of two elements. One is those vertical elements, which are actually precast elements, and then the glass, which is high performance glass. We have got photovoltaic cells on the top portion of the crown, and then sky gardens at individual floors. So this is what is, they are all actual rendering pictures of this project, where we wanted this to happen across the periphery of the building, the decks and the podiums. This is a very important factor, how to make your building earthquake resilient. So the central core, as I said, it's going to take care of your seismic forces, and then the peripheral columns, they are only taking care of the vertical load. The wind tunnel testing will be done for this. This is the structural system what we are suggesting. All the peripheral columns are composite steel columns, where the steel tubes will be filled with concrete, and then the steel decking sheet will be used. On the steel decking, you don't really require any shuttering. You just pour the concrete, you leave the steel shuttering as the decking sheet as it is. And from below, if you have noticed, all the structural members are plastered. So that is a fireproof vermiculite plaster. Then to take care of the lateral force, viscous dampers will be introduced at intermediate levels. Then for fire safety, this is one additional provision, that is the sky bridge, which is connecting these two towers together. So you get alternate means of exit. Then staircases and lift lobbies, they are pressurized. Maximum chances of fire are due to the electrical cables. So that is avoided with bus bars. So we'll have rising mains through which the electricity will be provided. Then separate fire lift is there, and separate fire staircase is there on the outer wall. You can see it here. Then refuge area across the periphery. And then a core has got multiple entries and exits. So even in the office floor plate, you can actually run into the core with various exit routes. So the core is designed in such a way that you have got maximum options for exiting. And then the sprinkler will be provided. All these fire requirements these are the codal requirements will be taken care. Very important part of the parking system is compartmentalization, where in case of fire, the smoke doesn't really enter into the other compartment. So this is how the compartmentalization will be done. And then the exit distance. So from any point to the staircase, the maximum exit distance is 30 meters. So if you see all the staircases which I have in my complex, they are covering the entire footprint of the basement. So you have to place the staircases in such a way that one need not travel more than 30 meters in case of any mishap. So the normal firefighting system, what is required, the codal requirements, fire detection, alarm system, I'll skip this. Public address system is very important part of commercial buildings. Access control. This is from safety point of view, the barrier, turnstile and the flap barriers are very important because you don't want the public zone and the private zone mixed up together. It is very difficult to manage that way. And when these kind of buildings are mega buildings where more than 15,000 people will work. So in such cases, to segregate them at the entry level. So there are multiple entrances, multiple lobbies, and you segregate them with multiple options like RFID, fingerprint, and face recognitions. Then surveillance is very important part of safety and security. And in a pandemic-like situation, what you do, like the elevators will be touch-free elevators, and then the lobbies, you need to have huge lobbies. Like if you see, the lobbies are so spacious. Here, the lobby is like double-height lobby. For these 3 elevators, there is huge space to stand there. The main entrance is here. So we have segregated those different entries. Like this is lobby for the express elevator. This is lobby for the amenity floors. And this is lobby at the lower level. So we have got 2 different entrances. The pedestrians are entering at the ground level. The vehicles are entering at the top level because the porch is raised. And that if you have noticed that mount there, so the vehicular access is at the top level, so that you've got multiple options of entering into the lift core so that they are segregated properly. That is what is also needed in current situation. So this is the ground floor plan. The ramp goes up at the first floor level. This is the entrance. We have this atrium happening here. Then the entries to the sky lobby. Now the sky lobby is giving access to the restaurant and those VIP offices above the viewing gallery, and the entry to the this express elevators through this double-height lobby is there through the flap barriers. So these are controlled areas. There are these coffee shops and cafeterias on this side. Then we have got toilets and common toilets on the rear side. In the front side, we have got these retail areas with colonnade. This colonnade is basically for the pedestrian to segregate from the vehicles. So this is the lobby. This is the first floor plan. Now at the first floor, you come at this double-height area here. And you have got different set of amenities there. The atrium, and then we have got one more lobby which is at the lower level, the rear side, and there are few elevators which are directly accessible from there. So this is one drop-off which is happening for the higher taxis. So we don't want higher taxis to come from the front. At this level, this entry is not there. At the ground level, the entry is here. So through the colonnade, you enter through this entry is here. So these are the pedestrian entries, and the vehicular entry is at the first floor level. Yeah. Yeah. So these are the first floor, and this is how the entrance on the ground floor and the first floor is happening. So this is that first floor entry going top, and then this is that colonnade which is giving entry at the lower level lobby. So on the second floor, we have got this auditorium, and then we have got different lounges, lobbies, business centers. These are the amenities for the offices. This is view from second floor into the first floor double height entrance lobby. So this is the third level where we are actually seeing the double height auditoriums top part. Then we have got banquets, and we have got a huge food court, and we have got a restaurant. So all the eateries are here. Some fine dining is there, a part of the food court as well. And this is the level which is connected with skywalks on both the sides. Then there will be a security check, and these two elevators will either lead them to the entry level if they want to enter into the building, or if they have got enough accessibility, they can go inside these areas. So this is a schematic section. The sky bridge is connecting that second floor level. We have got double height retail space. This is a colonnade here. We have got 5 basements that is allowed in Bangalore, and that is mandatory kind of. And then we have got these amenity floors. Then upper deck level, this is the top level of the podium where we have got this amphitheater happening here, and then the towers above. So in this section, you will see those 2 skywalks connecting at 2 sky lobby levels, and then we have got these refuge areas across the building. Very important factor is how you achieve that efficiency in the park in the lifts. So in the single shaft, there are more number of elevators. If you see, they are segregated. Some text is missing here. So these blues are the express elevators. These express elevators, they actually take you, the blue elevators, they take you to the lobby at this level, which is actually a sky lobby connected with the sky bridge with the other tower. And from that, you can actually take separate set of elevators to go up or to go down. So that separate set of elevators are actually the cyan color elevators. You take them to go up. So you come here by elevator set D, A, E, and you enter into D. And then in the elevator set D, you have got one set of elevators which are happening at the lower level. So you will see there are actually 3 sets of elevators. There are few elevators which are connecting the lower levels here. There are few elevators which are connecting here, and then there are few elevators which are connecting here. So in one shaft, there are actually 3 sets of elevators. That is how you achieve your efficiency. So there are softwares. There is software called Elevate, which simulates the user load and then the movement of the elevators and how you take care of that movement of the people. So the sky lobby here, as well as there is one set of express elevators which are stopping here, and that is going to take care of this portion. So you have to do it very carefully. Then, like this set F, it's accessing only the sky lounge. So it is not stopping anywhere in between. It's an express elevator which will stop only at level sky lobby level, viewing gallery level at the crown. And then from there, it will lead to the restaurants and other areas, other levels. Why we need express elevators? Because see what happened when we have these high-speed elevators, If you allow them to stop on every floor, then before they take their complete acceleration, the floor will come and they will never achieve that efficiency. Because even if you have 9 meter per second elevator, which is like 3 floors in 1 second, but if it has to stop on every level, you will never be able to achieve that efficiency. So that is why in most of the high-rise towers, super high-rise building, this concept of sky lobby, express elevators, and multiple elevators in single shafts are to be used. So this is the 4th level plan. In the schematic section, you can see where it is. And these are again those co-working spaces. And on the rear side, this is a wellness center. These co-working spaces, you will see the accessibility of the outdoor seating is given to these co-working spaces. The floor which is just above it, few more amenities in the clubhouse. Again, it's a co-working space. This is elite activities in the clubhouse at the rear level. And then the gymnasium now on the 8th floor level, and fine dining in the corner with the surrounding take terraces, so that there were a lot of outdoor spaces surrounding those fine dinings. And then the typical floor from 11 to 14, and from 15 to 16 are like refuge floor area. So you will see it in the section, schematic section. And you can see the way we have actually divided the offices. This is the core, and office will have direct entry from the core itself. So there is no corridor as such. So you can actually divide this whole floor plate into 7 offices without actually adding a single square foot of corridor. This is a complete floor plate, 17 to 24, 29 to 32, then 27th floor, the first sky bridge level, then 30, 33, 35 to 38, the upper sky bridge level, and then a restaurant on top of it. Again, outdoor sitting area, the terrace is forming there. Again, the typical floor, 49th floor, a small terrace is forming there. And then typical floor, 51st to 52nd. And then the top level, 53rd floor, 54th and 55th floor, the offices. Now you can see very few elevators are accessing those offices. They are dedicated elevators, the service elevators are there, and the minimal requirement of the core is there. Then, of course, for this kind of public building, you need to take care of all those for physically handicapped people. All the toilets, ramps, staircases, lifts, walkways, they need to be taken care. Now, sustainable building design to take care of the urban heat island effect. All the terraces are converted into softscape or something which is which will take care of that heat island effect. Then these are few features which we have used. We don't really want maximum turf or lawn area, because they are not really good for green building, but they are minimized wherever they are required. Maximum shrubbery and plantation, the trees are there. Building envelope, glass is very carefully chosen. The vertical elements I have shown on the top level, where I have that glass cuboid as a crown of my building. I have got those horizontal sun shading devices, and then a combination of DGU and low E glass. That is what is going to give me the efficiency in energy. Then water management. All these features are there. We know minimum minimum water exchange, water use. This fixtures are there. Then we are going to use double flush wall, and then we are going to use a lot of percolation happening. All the paved areas, all those permeable paved areas, so the groundwater will be recharged. Roll of colors, very important factor. So we have used all light colors in the horizontal surfaces so that to reflect maximum sunlight. And then all these elements, simulations, they are part and parcel of our architectural design. But because the architectural character itself was so powerful, we found that hardly anything additional was needed. Local material we are going to use. So we have got a lot of granite in Karnataka. This is very important. This is the footprint of the trees, this is the greenery which is there on site currently, and we are only using 10%. So this is what is the existing buildings. These are the existing buildings now, and this is our design. So we are hardly touching any full-grown tree there. This is an important factor of this design. So we are using this monolithic insulated concrete system, which is a composite steel concrete system, where the steel member, a hollow steel member, will be filled with concrete. And then this particular system doesn't really require supporting scaffolding system. So the members are executed. This is factory in Bangalore itself. So this is the kind of beam member which is being fabricated in the factory, and this is a column member which is being fabricated in the factory. And then without any support, the beam will be erected on the structural members, and then concreting, second phase of concreting will be done. So if you note, the part of the beam is already there, and once this is placed properly in place, the remaining concreting will be done. So this is a composite system which is fully self-supporting. As I said, there is no across props which are required. This saves a lot of cost. This is quick, saves a lot of time. Then this is fire safety is there because most of the members are encased in the concrete. This seismic resistant. The sections are very narrow because this is a composite system. So the sizes of the members are very less. As I said, this fire resistance is very high. And then larger lasting building, the building life is more because the main structural system is steel, and then flexibility is there. Okay, I'll skip this. This self-financing scheme. These are energy efficient features of the building. I'll skip them, but there are a lot of them we have discussed on that. Inside the office also, we have got the combination, how the passive ventilation is done, how the recycling is done, everything is there. Like IBMS is a very important integral part of smart buildings. So they take care of everything like air conditioning, ventilation, lighting, hydraulics, access control, CCTV, fire detection, lifts, and many other things. When we say ventilation, let's say there are 5 basements. So you cannot keep all your exhaust fan running all the time. So you have got those carbon monoxide detectors. As soon as the level goes above permissible level, they will start operating the fans. Something similar is going to happen with the common area lighting. So the sensors do a lot of energy saving. Even in the curtain walls, in case of fire, the automated panels open up and the exhaust will start working in case of some double height areas. So that kind of IBMS system can be integrated into the building. Then the requirements, building and development requirements, I'll skip this. Okay, these are a few architectural elements like sky bridge. You can see something, same vocabulary of architecture is derived from the building and integrated it into all these elements. The colonnade, you will see something similar. The spire, as I said, it's a very important element, aesthetical element for our building. And that's it. This is the second case study. Ma'am, do we have time for the third and fourth? Harshada, ma'am?
Yes, sir.
Okay, so I'll take 35, 40 minutes more then.
Okay, fine.
Okay.
No problem.
This is one building we are doing in Mumbai. This is at Worli. So this is the layout. We won this competition. It was an international competition held in 2016. This is kind of biggest urban renewal project in the entire South Asia. Almost like 3 crore square feet in total. And we have got the roads. So this is it. We have got around 33, 40-story buildings. So all these small buildings, what you see, are 40-story buildings. We have got 10 74-story building, and we are going to talk about the central building, which is a commercial building. So this is a 60-story commercial building. And this entire development, already work has started. Tata Projects are my contractors there. Government of Maharashtra is my client. So this is the first of its kind development Government of Maharashtra is doing as a developer. And the entire layout is like, we have got almost like 8,893 existing chawls there. These were constructed by Britishers almost 100 years back, and they are in a very dilapidated state. And for very long time, there is a redevelopment attempts are happening, and currently the government is very active and very prompt, and there is a lot of willingness to do it on war footing. So the work is moving very fast. We have got some non-residential tenants. We have got schools. They are the tenants. These are the units of schools. Then we have got boys' hostel. We have got hospital units. We have got municipal dispensaries. And a lot of these slum dwellers as well. And there are some stalls. So altogether, like 1,150 odd members are to be rehoused, reconstructed, and then the sale component will take care of the construction or entire funding of the project. So if you know about this location, this is a very prime location in the heart of Worli, exactly in front of sea. I'm 500 meters, exactly 500 meters away from the sea. I got this one main road, this is J.M. Bhosle Marg. I got one other road, this is GJ Marg, and I got one approach to that road, which is going to give access to my commercial building here. So this is a very known place where a lot of national leaders have given their their lectures and speeches called Jamburi Maidan. And in this entire layout, I wanted this particular element to be a focal point. When you come from the ceiling, Bandra-Worli ceiling, this becomes a focal point of that. And we had huge FSI to consume, particularly for this plot. This is how the view is there. So not many high-rise building in front of it. So this will be kind of the tallest commercial building going to happen in the radius of almost like 3-4 kilometers. And there are a few commercial high-rise towers the nearest near vicinity, but they are not at this site today. I got good sea view on one side. I got partial sea view on the other side, and then on the opposite direction also, I got some good scenic view. So this is how the entire development is there, and this is where my residential buildings are going to be coming up. And this is the place where I'm designing this commercial building. So the entire concept is on exoskeleton. Here I'm using a central core with a exoskeleton skin, a die-grid exoskeleton skin with composite steel. So these are not exactly the one which I showed you before in the previous project. These are going to be the hollow round pipes filled with concrete. And you can see the lower levels are at podiums. And then on the upper levels, this outer skin is there with slabs in between and the different floor plates as per the shape of the building. And then this forms the character of the entire building. So the whole building design, right from the structural system, the basic structural system, not the design part of it, the facade and the shape, everything was designed through parametric softwares, including the smallest detailing of a mullion and glass. So I wrote this definition to create that entire building exoskeleton and structural system. So this is how it is going to work. So if you note, these are those stars which are little bigger on the lower level and they become slender and almost get parallel as the system goes up. The parking is very interesting here because again, this building is going to take care of more than 14,000 people working in the building. So I needed multiple entries and exits and vehicular traffic to be separated and pedestrian to be separated. So I used both the roads for my entries, exit, and particularly for vehicular traffic, I used big 9-meter ramps to reach up to the drop-off level, and thereafter I got two separate set of ramps, one for going up, one for coming down, 6-meter in width. So they are actually two double driveway, one-way ramps, and this is how the parking is working. So once I start climbing up, the blue one is for coming down, the green one is for going up. So once I start going up, there is this drop-off area, and then I have to just keep on climbing up, and then I reach to the 8th floor level. When I have to come from 8th floor level, I come down, and then there is this drop-off, and then I come down this way. So instead of just taking those rounds and rounds, those helical ramps here, because the levels are little more, number of parkings are more, I've tried to achieve that efficiency of movement through minimum bending kind of thing. And these are the podiums. So this is the render of it. So we have got this podiums at the lower level, drop-offs, and then the tower is actually a different, a separate structure. You can see those residential towers in the background and on the sides. So at the ground level, if you note, there are these two drop-offs. So one drop-off is happening here. So this is my taxi drop-off. So they have to enter and they have to exit. And this is my lower level lobby. Then I got this rear lobby, which is for restaurants and sky lobby, sky lounge. So the person enters from here, and then there's a drop off, and he exits from here. Again, lifts are very important. Average waiting time I have achieved is only 35 seconds. Average travel time is 55 seconds. And my express elevators are 9.1 meter per second speed. And the sky lobby, again, something similar is happening. The way I explained you here in this core, the yellow are my express elevators, and you can see the express elevators stopping at the sky lobby level here. And from there, I take the green elevators. If you see in the left-hand side section, I take set of green elevators to go up or go down. So these are the green elevators. Okay, so and when I come from my elevator, express elevator out, at that level, the purple elevators are not there. So I enter from this, enter into this space there, and directly enter into the this set of green elevators. When I say set of green elevators, they are synchronized elevators. So all these are going to be destination controlled elevators. So once I set the destination, it will tell me which elevator to take. So once I enter the elevator, I don't have control where to stop. And there are these blue elevators, which are express elevators for my sky lobby and restaurant. So they stop directly at the top level here. You can see that. So the ground level, as I explained, lobby at lower level, in the front, in the back side, then I got those multiple checking. Like at a time, there will be almost like 16 cars can be security checked, and then they will either take lower lobby drop off, or they will take the ramp to go to the parking levels. This is the first basement. I got loading unloading here, and then I got loading unloading lifts here, and then when every minute detail is done, when the workers toilet, everything is there. So this is the second basement. Again, my parking is very efficient. You will see all the driveways in one-way movement with doubly loaded. That means they have got parking on both the sides. Third basement level. And this is my first floor. You know, first floor, I come with this ramp here. And then I got a drop off at upper lobby level. So at that time, the lower lobby becomes double height. So this is a double height here. This lobby is double height on the upper floor. So I got these double height lobbies at lower and upper level. This is a drop off for my vehicular traffic. And then above that, I got that double height lobby space below, and then I got two-wheelers parking on the end here. And then I got typical podium. Now here you will start noticing the movement of the ramp. So one ramp is going up, one ramp is coming down. So the yellow one is coming down, the pink one is going up. So you will see the movement happening here. So every time the position of the ramp changes, as I said, the ramp is keep on moving, so that the person will climb along the ramp. Yeah. And then on the top level, this is the E-deck level. I got swimming pool, and then I got club and other outdoor activities. So almost like 1,580 parkings, four-wheeler parking. That is what we have accommodated in this. These are the different level plans where we have got those different iterations or alternatives for the sizes of the offices, because this is a government building again. And the offices, I don't know exactly what is the requirement today, but then right from 728 square feet to 3,000 square feet of office spaces, I can have complete floor plate of smaller offices. Then if you note the central core, now the lifts are removed depending upon the stacking system of my lifts. Now this is the space which is not actually having any vertical movement. So I have converted them into toilets. So when I got toilets in the common area, I removed the toilets from the offices across. When I got offices and no common areas in the lobby, you'll find the toilets are there, and every toilet has got a shaft, ventilation shaft there. So this ventilation shaft is right from the bottom, and it is giving ventilation to the staircases, to the toilets. Here you'll note that the express elevators are opening on the opposite side. This is the gathering space, and from here you have to take the elevators to reach to the next level. So you'll have to change your elevator here. This is the sky lobby level, and then this is a typical floor. If they want only 4 offices on per floor, then how the floor plate will be divided. Very minimal columns, and then the restaurant and viewing gallery. This is the view, the body of the building. The structural system is very peculiar. As I said, I've got huge column free space there because the leasable area I want more. I don't want restriction on the sizes of the offices. And the tag grid system is my facade as well as my structural system. So that is going to take care of the gravitational forces. All the lateral forces, as I explained, will be taken care by the central core. Then again, I got steel deck slab. So this is how the steel deck slab is constructed. The GI sheet is laid, and then on top of it, the minimal reinforcement and the concrete slab is casted. So it takes very minimum time, and you don't have to worry about the shuttering at all. This is how the central tag grid and core is going to work. It is going to take care of the lateral forces. The tag grid is going to take care of the lateral forces. I've taken care that the junction of those tag grid, they are going to go straight without any floating. And this is how the deck slab and the steel beams will be there. The central core, the tag grid in the periphery, and those steel beams. And top of that, there will be deck sheets. So you can notice those cutouts in the beams. And they will be vermiculite. They will be cladded with vermiculite plaster for fire safety. So tag grid, the gravitational load system is very well known. All the skin will take care of that forces. We have done the ETAB model of the entire this thing, and we check the deflection, X and Y direction deflection, and the period of sway. And we have come to a very under permissible limit kind of displacement for wind pressure. So this is a very efficient system. We could not achieve the same with the concrete members without tag grid. And then the force distribution, I'll skip this. These are the junction details, how the tag grid will be casted. Now this is not the exact what we are going to do. We are going to use the vertical round tubes, but this is what is the important factor of selection of this structural system. If you go for a tag grid, you see the amount of concrete it is consuming. This is a conventional method. The concrete consumption is more in a conventional method. The steel consumption is almost more than twice in a conventional method, whereas tag grid, it is, you can see the comparison. And the service level modeling, the composite floor, the core walls. There are the tag grid members at various levels. Stage distribution, construction methodology. I'll again skip this. Internal testing, yes, I'll skip this. And this is the facade which is going to be there. So we have got this internal structural member, and the outer, this thing is cladded with composite panel, solid core composite panel, and then the glass. Most of the time in structural glazing, you don't really connect it with the member. And we have, as I told you, I have seen the negative points of that connection of facade system with the structural system. In Jinmao Tower, I told you, in the hotel, it was a nightmare kind of thing. But here we have kept a provision where the structural member is not directly touching the facade system. This is the entire view. Landscape has got again many design considerations. So we thought of different policies for designing the facade of the podium, because it's a massive structure and it's a bulky massive structure which is visible from the road level. So we wanted some green curtain kind of thing to cover it. So this is section type 1, where we have got those flower beds coming in and out of the building, and we have got that plantation happening on it. This section type 2, where we have got those in line, and then section type 3, where they will be accessed at the lower level by those scissor lift platforms, and the kind of vertical landscape can be maintained. Now, this vertical landscape is not the vertical landscape which we generally see. This is into the planters which are accessible from the parking areas. So I don't think there will be any issue in managing them. Then there is a concept of vertical forest. So there are these 3 different strategies we use. So the first strategy is vertical forest. So we have got selection of those plants and those trees in such a way that throughout the year they will give that forest kind of effect, and you can actually see that entire facade with those plants, and we are going to allow the birds to nest inside. Now, if at all we want to put the bird net, that will be from inside the planter. So we want birds and butterflies to habitat there. And then there are different strategies where we wanted the top layer to be a cloud effect, the central layer of the facade, the podium facade, to be seasonal and dry, and lower one as evergreen. And this is one design approach. Then ecological billboard is what is the other concept we adopted, where the entire facade will be divided into the mountain kind of pattern with different shades of trees, and we can have some kind of ecological message given to people, something like the trees are absorbing air pollutants, or you can have some distant appreciation of some species which are going to be visible there. So something like this can also happen on that area. This is the final picture, and this is one part which I like most, the lighting of this particular building, because it's a diagram. This is the daylight, and at the podium level, this is the illumination. At the crown level, this is what is going to happen. But this is the best part of it. The kind of permutation and combinations I can achieve through a single lighting system, a pixel lighting, can be enormous. So I can have something like this, I can have something like this happening. So incline fins kind of effect, where they will go one by one, and in festive season like 15th August, I'll have tricolor on the building. Or I can have something like this, maybe this, or this. So this is one lighting fixture which is going to give me all these possible combinations with just this kind of pixel lighting. On top of the reach of that design element, I can have those multiple permutation and combinations. And this ends the third part of it, the third case study. This is the final case study. This is an iconic steel tower we are designing. And this whole story started when they said, yeah, I have to design a 350 meter tall iconic tower. And they wanted something similar to Eiffel Tower and Tokyo Tower, and Steel Authority of India, they didn't disclose the location. Now I don't know the location, but there is a lot of a lot of things happening in this project, including politics and a lot of issues. So when we say 350 meters, look at all those iconic towers across the world, and Eiffel Tower, once you say Eiffel Tower, it's so symbolic, and something similar to Eiffel Tower or Tokyo Tower is not going to be that creative, but then that was the design brief. So Eiffel Tower is 324 meters, Tokyo Tower is 333. So the design brief was 350 meters. We started with form finding, and I used again parametric softwares to find the form. This was one launch I had designed in 2018. Now why I am showing you this, because the whole idea was originated from this, and this was a 15 meter by 6 meter structure made up out of paper. So I use paper as a structural element. So if you see all these elements, they are just folded papers. We have kept few samples here, if you see, and this is how it was. And this was that paper element. The paper was 2 mm thick, kind of sunboard, and when you get one element like this, 110 gram element takes load of 40 kgs. So that gave me the idea, and because Sterling Engineering was designing this structure for me, so I shared this concept with them, and we started evolving the form. So I started with a very basic form, a curvilinear one, and then divided that into levels, then added that one restaurant level, one sky lobby level, and one viewing gallery level. And this is how the entire form was originated. Then I wrote the complete definition on Grasshopper to create a structural system and aesthetical element. Now this is very difficult to do it with any manual method. So this entire geometry was generated through parametric, and this is how the final form evolved. So this is the entrance of that structure. So at the lower level, there's an entrance plaza and the ground level. Then I've got a viewing gallery and a restaurant at 100 meters level. Then one more restaurant and a public amenities at 200 meters, observatory deck at 300 meters level. And this is the model, the digitally printed model. Now to achieve this kind of structure or this kind of geometry, not just from architectural point of view, but from structural engineering point of view, you require digital softwares. Manually, none of them is possible. So the stability and the load flow, you can very well imagine it's a pylon. So everything is going on the ground directly. Then the most important was nothing is cantilevered. So every element which is you are seeing jetting out of the form is part of the form itself, and it's not a cantilevered element. The central core will be doing in slip form. It has got number of elevators inside. Few lifts are stopping at 100 meters, then the 200 meters, 300 service lift is accessing all the floors. So the central core will take care of the entire horizontal forces, but the pylon itself is so stable that it doesn't really need that kind of support. For fabrication purpose, we divided every star into a small plate. So the maximum size of the plate, they said, will be 4 feet by 8 feet, then they increase it to 5 feet plus. So we wrote a routine routine in the software to divide the surface into smaller triangles, and those plates will be bolted together. So wind pressure, as I said, it is going to be more stable structure because of the shape itself. This is the rendering, and this is a festive lighting. Thank you. And that ends today's presentation. Thank you.
Thank you very much, sir. Very beautiful, wonderful, and interesting presentation. Now we will have a question and answer session. Let's see if we have any questions in the chat box. There is one question from Uday Govalkar. What are the important factors to be considered for good space planning for podium designing? For in bracket, they put calculations of permissible construction area, permission from municipal authorities, and designing spaces, which are permissible.
So now every bylaws has got different provision for podiums. So Mumbai bylaws says the parking podium cannot go more than 32 feet. So that forces you to take the first terrace level at 32 feet. But then in many places across India, I don't think there is any restriction as such. But need not be every horizontal terrace need not be a podium. It can be an offsetted terrace or a projected element, and you can beautify it. Why particularly podium, that I could not understand. Ma'am, he asked something else also, right?
Yeah.
What was his
what was the important factors considered for good space planning for podium designing?
Space planning for podium. See, if the podium is for parking, then the most important is efficient podium. So when we achieve efficiency of, let's say, around 28 square meter per parking, that means including driveway and parking, I consider that the best. And it's very hard to achieve. 35 square meter per parking is something which is, I consider as fairly good. Anything above 35 is not advisable. But I have seen many designs in India where the efficiency is around 50 square meter, which is criminal waste. So if you're just talking about space planning from parking point of view, I think that is one very important factor. And the other factor is convenience of the parking. So as I told in my presentation, the parking movement should be one way, as far as possible one way. The movement of the ramp should not hamper the movement of the driveway. Somebody is taking a reverse and it's a part of a ramp movement, then it will cause some accidents. So that is one factor. Dead end should not be there, because somebody is trying to find a parking and he reaches to the dead end and he has to take a reverse. So those kind of situations, the turning radiuses, that they are very important, because if you don't provide proper turning radius, then probably you'll end up into brushing the edges, the corners of the vehicle to the parapet walls. So these are basic factors, space factors. I don't know if the question has got some other aspect as well.
Other than parking, also you can
see. Other than parking, there is a podium, which is a terrace. I don't consider that as a podium then, because if you are using any bigger block or bigger mass at bottom, other than parking, then it is a block. It's a usable space. So it's a horizontal surface, it's a terrace. Then terraces, I don't think that is the question. So I think podium is only for parking.
Okay, Uday sir, I think sir answered your question. Students and participants, if you have any other question, you can type in question answer box or a chat box. I have one question, sir, that what is the process or parameters you follow while developing elevations, massing, and facade? Actually, you answered this question also, but any other thing remaining other than that? All your presentation was in such a detail. So I don't think there must maybe any questions.
Okay, see, particularly when it comes to commercial building, all across the world, they have got the tendency to make the form first and inject the spaces in between. In fact, the foreigners are fascinated to this idea so much that they even use the same for residential buildings. So if you find the high-rise buildings across the world, they are like injected the spaces inside. So when it comes to residential high-rise building, I'll never prefer a sample case of a Middle East, like Dubai or Doha, even for that matter, Miami buildings. Yeah, Miami buildings are, few of them are really good, but not certainly Chicago buildings. But if you really want to see a tropical residential high-rise building, then I always will look at Singapore or Miami. My mistake. Miami is a good example for residential. So then it is different. See, you have to design a function first, and then come to the elevation. For commercial buildings, the formula is always same. The structural system and the form come first, and the spaces become secondary.
One more question is there from Tanvi Ganorkar. What is your view about sustainability in buildings? Do you consider it to be a costly affair or need of the hour with respect to small scale or large scale buildings?
Okay, see, this question is asked to me many times, and every time I give the same answer. We actually see different aspects of sustainability. From my perspective, sustainability comes in two ways. One is the quality of space. Okay, whether that building is a livable building. Many buildings become sick buildings, the air quality is not good, then that building is not sustainable because it has lost its function, basic function, that is to provide a habitation for human beings. And the second aspect is the longevity of the building. So if you are using any material, something like, let's say, concrete will never be a sustainable material. They will have to find alternative technology for concrete, because once the concrete building is demolished, you don't get anything out of it. You just get a debris which is environmentally harmful. But just imagine a technology. Now you take even concrete, human life is 80 years, concrete's life is 60 years. How that building be called sustainable building? But just because of the World War II and the humongous task they had to construct and rehabilitate all those people, the concrete technology became popular, and it has no alternative today as such. But eventually they'll find it. But sustainability is longevity. So any material what you use should last long enough, at least for one human life. It is must. I don't think there is any alternative. Saving energy is something which is really very important, and that pays you back. It is not a costly affair. So we have tried residential platinum rated green building, like one of my project, Vanavigna Park, that is almost like 28 lakh square feet single building, 61 story twin towers. It's a platinum rated green building. But I consider that building as a success because of the energy saving features. So if you have got enough energy saving features, I think that's fair enough.
There is one more question. I think Tanvi, architect Tanvi, you got the answer. There is one more question from architect Prashant Joshi. Sir, can you provide some basic guidelines to design service floors in high-rise buildings?
Okay, so what happens in high-rise building, the service floors are basically used for one main purpose, that is brake pressure tanks. See what happens when you have only overhead tank above, the pressure in the pipes is so high, and the pressure reduction valves, they generally tend to fail, and that will damage the entire plumbing system. So the better way is to provide the break pressure tanks, which will be at after almost like 20-30 floors, depending upon the requirement, and the looping of the piping is done at that level. So in the residential high-rise buildings, we are doing almost in all the buildings. For commercial buildings, we try to provide that into near to the refuge areas. The basic reason why you need complete entire service floor, particularly for residential buildings in India, because the toilets ducts are in the periphery, and the piping looping has to happen in the periphery, so that almost it's over the entire floor. But then in commercial building, you can avoid it. The toilets can be near to the core, and you can actually utilize the remaining floor plate. So there are different ways of doing that. Besides that, there were requirements of fire check floors, but currently they are eliminated. No more fire check floors required. But instead of that, now in the facade, in the glass facade, it is mandatory to provide fire drenchers. So all across the periphery, you need to have those series of sprinklers. That is a mandatory requirement nowadays. But just few years back, maybe 2-3 years back, the requirement was little different. Almost every 70 floors, they used to require a fire check floor, which is a service floor with a header pipe running all across periphery with drenchers. But that requirement is eliminated. Second, what you can do, instead of providing maybe toilets or your meter rooms on ground floor or on every floor, when you use rising main bus bars, then you can provide a meter room which is on every floor. And nowadays there is a software called SCADA, which connects all your meters with the computer, and in very near future, maybe within next 6 months or a year, they will be start reading your meter from their office. They don't need to visit your premises. So that is happening even in residential building nowadays. So initially the concept was you used to keep the meter room at the lower level, and then the cable used to go up. Now it's not advisable, because the fire hazards are more in cables. So the bus bar goes up, and on every floor it is tapped with cables, and the meters are provided on each floor, and the cable goes inside the premises. So instead of doing that, you can have meters on your service floor. So you can have those service floors for your break pressure tanks and the meter room, so that you don't have to provide meters on every floor. So I think that is those are the only two uses basically, unless there is a shifting of pipes or the piping which is coming from top, like there are mixed use developments. We are doing 2 towers with 5-star hotel on top. So the plumbing system which comes from top needs to be diverted. If that is to be done, then only the service floors can be utilized. Otherwise, it's not advisable. Moreover, we used to float the columns. Even I have designed a building where entire grid is floated with a shifting girder. A 50-story tower is placed on top of the mall with a shifting girder, shifting plate, which is almost 3.6 meter thick, casted there at the 12th floor. So in such places, you need to divert the pipelines there along with the columns. There you need a service floor. But I don't think it is advisable, because in the new code, in the structural code, now any shifting of a structural member which is taking lateral load is not allowed. So gravitational column, you can float. The column which is taking a lateral load is not allowed to be floated. So I don't think you can use it even for that purpose.
Okay. Let's see. There are many more questions coming. From architect Prashant Joshi again. Can you provide some basic guidelines to design? That's over. Then Arun Atre sir, engineer Arun Atre. Do we have AC system as sustainable as the well-designed green building?
Okay, now integrating your AC system along with your other usages is very interesting. You can always have those innovative AC systems where the circulation of hot pipes or cold pipes are going through the floors. They have got maintenance issues, they have different issues, but then the easiest is you connect your AC system with your heat pumps, because every building requires hot water. If it's a residential building, it will always, or maybe mixed-use building where there are, the hotels, hotel rooms are there. So it will require hot water. That hot water can be generated out of that hot air out of that AC system. Of course, that is not sufficient. You'll have to have heat pumps as supplementary, but you can integrate these kind of systems. If you maintain your wall-window ratio properly, if you see to it that the heat gain is minimum, then you can increase the efficiency of your AC units. Nowadays, we used to prefer those water-cooled chillers in large developments. Even people are not preferring them nowadays. People are moving towards BRV system a lot. Because of energy saving features again. But when it comes to green building as such, right now the norms are restricting you to the usages of the refrigerant which is used inside the AC. So if that is there, that is one feature which is a green building feature, and the other is the energy efficient AC system. Like VRV, VRF, they are energy efficient system comparative to the other available choices.
Okay. Atre sir, I think this answers your question. Can I have one more question, sir?
Of course.
Yeah. I have one regarding the algorithms that you used, that parametric design you used in your project. So what will be the future buildings and how this digital architecture or algorithms will be useful in designing future buildings?
So I believe when it comes to parametric or digital architecture, people have got something, a stereotype in their mind. They always start visualizing Zaha Hadid, and it's not necessary. The simplest form of building can be done through digital architecture, through these softwares. So whether you want to make a complicated building or simple building, first, the use of technology is not restricted. When you use technology wisely and innovatively, it's an interesting feature. And then if you see all the good buildings across the world, innovative buildings, those we really appreciate as innovative buildings are digitally designed. So I see there is a huge scope for digital architecture as such. Parametric is one branch of that digital.
Okay, thank you, sir.
Let me ask you one question, ma'am. How much digital architecture or parametric architecture you teach in your college? Ma'am, this is for you.
In elective subject, we just introduce them so they can explore what is parametric design or digital related, like 3D printing, then 3D fabrication. So in elective subject, these things we explore. We ask them to explore. But as there is no master's course here, so that is not in detail. So only for the elective that is there.
Okay, so my suggestion is right from first semester, you can start teaching them softwares which are digital software, because there are almost like 80 different softwares. We use more than 60.
Okay. We are also
it's not just one software which is going to serve your purpose.
Yeah.
So we start training them right from beginning. That is what is expected in future.
This year we floated the 2 courses like Rhino and Grasshopper. But let's see how the response is there from second year onward.
Good.
Are there any questions from participants? Sir, I think there are no more questions.
Yep.
And it was very long, very informative, knowledgeable presentation in detail. It covered all aspects of from planning, designing, construction, detailing, everything was there.
I have tested their patience. Thank you for that.
I think there is from Akash Vadekar. Is it better to focus on specific type of structure or learn everything as students? And is there in use of algos and AI in our field?
Okay. So architects, their careers they are not designed properly. Our career always flows. Whatever you get, you design. So it's very difficult to tell you should be doing one specialization as such at this stage when you are a student. But certainly once you are out of your college, you will need to focus on to one aspect. Maybe the firm which you will be doing your job, the first job, will define your path in your future career. That is the first one. You can go in some office where only hospitality is being handled. Maybe IT is their specialty. Maybe high-rise buildings or whatever, the institutional building. There are architectural firms very specialized, and there are multidisciplinary firms. They do everything and do actually nothing, like mines. So that is your first question. The second is there is 100% use of algos and AI in our field. AI, I'm not really very sure of it, but algorithm, 100%. And then there are different method of presentation. Finally, architecture is nothing but presentation. You have to convince your client, you have to communicate with your client, with consultants, everybody. So presentation. So when I say presentation, the softwares which are there to help you to make presentation. So algorithm or parametric, they are not just designing softwares, they also help you to make beautiful presentations, and then renderings and maybe augmented reality, all that is needed. So everything is part and parcel of architecture. It's an interesting subject.
Yes, Akash, I think this answered your question. Sir, if you have time, we can wait, or shall we?
Ma'am, you can send me any question if somebody has got.
Okay.
And I'll be happy to answer on WhatsApp.
Okay.
And besides them, this presentation was to give them a little bit of orientation.
Yeah.
It will not make them experts, or the intention was not to train them for particular thing. The intention was to make them little prepared for what is going to come next.
Yes. It was really amazing presentation and the projects also.
Thank you.
So
Thank you.
If there is any message by considering your journey from JJ to until now for the students.
Okay, so ma'am, my favorite message is keep your attitude positive. And when I say attitude, I always say there are three different ways of attitude. attitude towards yourself, no lacunas, no superiority complex, inferiority complex. Second is attitude towards others, because you have to deal with your subordinates, you have to deal with your clients. So attitude towards others should be very, very important factor of your career. You get work because of your goodwill. You are appreciated because of your goodwill and your behavior. So attitude towards others is important. And the most important is attitude towards your work. And if that is positive, you believe in your career, you believe in your line, you believe in your qualification. I hate people, those who do architecture and then start construction company. So you have to have that faith in what you have learned. There are many people, those who ask questions, when everybody can practice as architect. What is the benefit of being architect? So I think that architecture is not for them. If you have got faith in your field, you will succeed.
Okay. Now we will move to vote of thanks.
Formality.
Thank you very much for this knowledgeable webinar. Sir, I'm sure that your inspirational thoughts and valuable guidance will definitely help all our young budding architects. We are highly obliged that in spite of your busy schedule, you accepted this invitation and grace this event with your presence and guide our students about sustainable, sensible, human-centric, nature-responsive architecture. I will summarize some points shared by you, like importance of structure is in high-rise building, design parameters, then like importance of column grid, core design, efficient driveways, then lateral forces, structural, cost-effective structural systems, orientation of buildings, then your design approach and elements of different elements of design, then understanding the design, then green building concept, and the ecological billboard, that was some new concept, and the aspects of sustainable designs. And also a use of algorithms and parametricism in your projects. So many thanks. And I would like to thank now to all the faculties, all the participants, and Professor Desle sir, then our team members like Architect Ranjit Nirlekar, for coordinating this complete event with full enthusiasm. And my special thanks to our Honorable Principal, Dr. Mahendra Sonamne, who took an initiative and making this webinar possible for all our students. So his focus is always on knowledge enhancement of the students, and they should know different philosophies of and the practices of eminent architects from all over the world. So we are also thankful for our dear budding architects again and participants for such an overwhelming response to the webinar. Thank you very much. Take care and be safe. So, yes.
Thank you, madam. Thank you for calling me here. And
yeah.
Thank you, Mahendra. Mahendra is, I think...
he's not well.
Thank you for calling me.
Yes. Thank you very much. So we'll conclude this session.